Okay, folks, so today what I really want to do is wrap up hypothesis testing. So we're going to dive into it. Before we begin, I do want to go over the process one more time and where we are at in that process. First thing we're doing is stating the hypothesis, the null and alternative. Then we're identifying our level of significance, which is alpha. We are then going to calculate the test statistic, which we've already done. And then today what we're going to do is we're going to compute the test by finding the critical value, comparing the critical value, and then deciding whether we're going to reject or fail to reject the null hypothesis. That will be today's goal, and this will be these videos will be the assignment for the week. I just want you to focus on that and get that done. If you can get that done, the rest of the year, if you understand this lesson, the rest of the year is going to be very, very easy. Okay, so let's go ahead and jump right back into our original four examples. Here with example 1, in Pennsylvania, an average IQ score of 101.5. The variable is normally distributed and the population standard deviation is 15. A school superintendent claims that her students in her district have an IQ score higher than an average of 101.5. She selects a random sample of 30 students and finds the mean test of alpha 105. Okay, so here is the information we have so far. Here's my null and alternative. First thing we did, say the claim was greater than. Level of significance, that's alpha, 0.05. Population mean, sample mean, population mean, standard deviation, sample size, standard error, which is the standard deviation divided by the square root of the sample size. This is the sample mean minus population mean, all divided by standard error. And then now the new thing here is to find the critical value on a Google Sheets. You use this formula right here, equals inverse normal of the area to the left of the critical value, comma 0, comma 1, because on a standard normal distribution, our mean is 0 and our standard deviation is 1. Okay, so once you come up with those two values, you're going to compare them. And the real question is here is, so remember, this critical value right here, that's this line right here. Because it's greater than, we have a right-tailed test. And I have that over here in the notes. Because it is greater than, it is a right-tailed test. Basically meaning, this is our critical value right here, this black line. This is the critical region. If the test statistic falls in the critical region, we reject the null hypothesis. If it's in this other region, we fail to reject the null hypothesis. So, since our critical value is right here, 1.645, our test statistic is greater than that. That means it's in this region right here. That means we fail to reject the null hypothesis. Sorry, we reject the null hypothesis. So we reject the null hypothesis. Now, if you want to go into more, slightly more advanced Google Classroom stuff, this is a basic if function. So I have it written as if the test statistic is less than the critical value, and then I have in quotations here because I wanted to spit out a string. Reject the null hypothesis. If it's true, if it's false, fail to reject the null hypothesis. But if you don't have to do that if you don't want to. Okay. So here's how we state that. Because we rejected the null hypothesis. And it has to be in context of the question that we are given. Since the test statistic is in the critical range, we reject the null hypothesis. There is sufficient statistical evidence to suggest that the IQ in the superintendent school district is higher than the state's average IQ. Now, please keep in mind that just because we've rejected, the big word here is suggest. We are just suggesting based off this one sample. Does not necessarily, one test does not mean anything. It just gives us a suggestion that it's possibly true. The only way to truly tell whether this is an accurate statement or not is by repeating this test over again with another randomized population. Okay. So let's go ahead and go over to our example 2. Now this one I'm going to primarily do through the calculator. I also did it on Google Sheets. but I want to do it through the calculator just to make sure that you all know how to use it on the TI-84. Okay, so example number 2. For a specific year, the average score on the SAT was 515. The variable is normally distributed, and the population standard deviation is 100. The same superintendent in the previous example wishes to see if her students scored significantly below the national average on the test. She randomly selects 36 student scores with an average of 500. At an alpha of 0.1, is there enough evidence to support the claim? Okay, so I do need to change something. I misread that. It's not 0.1, it's point. There we go. Alright, so I have my null alternative written out right here. So what I'm going to do now, because it is a Z test, because our sample size is appropriate, and we know population standard deviation, we're going to push statistics. We're going to go to test, the same place where we found confidence intervals. And then you'll notice there's our test right here. We're going to be using 1, 2, and 5 for our tests. So we're using a Z test. Our mu is 515, standard deviation is 100, sample mean is 500, sample size is 36. We're calling it a less than situation, and we're going to calculate. Well, right here, it's negative 0.9, the Z. This is our critical value our test statistic. That is our test statistics. That's what's anything I got here. Test statistic. It does essentially this formula for us. It does whatever situation we're doing. It does this formula for us. What it does not do for us, it does not find the critical value. So we need to do that still. Okay. So the way we figure out our critical value is on the calculator is that we're looking for something left of this value right here. This area right here is 0.1. Why do I know it's 0.1? Well, my level of significance said it was 0.1. So I go to inverse normal. The area to the left is 0.1. Mean is 0, standard deviation is 1 because it's standard normal distribution. And there it is. There is my critical value right there. Critical value. Now you compare these two. Does this number, the test statistic, lie over here to the left or to the right? Well, because it's bigger than negative 1.28, it lies right over here. So we fail to reject the null hypothesis. Want to make it better. There we go. So, since the test statistic is not in the critical range, we failed to reject the null hypothesis. There is not sufficient statistical evidence to suggest that the two students have a lower SAT average than the state. Now, I wanted to have these two examples next to each other so you can see the difference in the phrasing. Because one we reject, one we fail to reject. So hopefully that will help you figure out the formula a little bit better for you. If you have any questions, please hop into my office hour. I'm going to see how much time I have. Okay, so I'm going to go ahead and create another video in a sec for the next two examples.